Trigonometric functions in the unit circle. A unit circle is a circle with a radius of 1 unit. Because the value of r is 1 for each point, x, y, on the circle, the trigonometric functions of theta are defined as the sine would be the y value, because we know that sine is always the opposite side over the hypotenuse. And so whatever this is, this would be the y value of that coordinate pair, and it would go over 1, and the y value divided by 1 would just give you the y value. The cosine of theta is equal to the x value, because we know cosine of theta would be the adjacent side, and this would be the x value of our coordinate pair over the hypotenuse, and the x value divided by 1 would just give you x. So the cosecant of theta would be, hold on, I skipped tangent. Let's go back to tangent. So tangent of theta, well, tangent is always opposite over adjacent, and so this would be the y value of the coordinate pair would be how tall it is. The x coordinate would be the length of the space. So opposite over adjacent means that tangent is going to be y divided by x. Cosecant of theta is the reciprocal of sine, so it's 1 over y. The secant of theta would be 1 over x. Cosine of theta, typo here. We mean cotangent. Cotangent of theta would be x over y. So we can use a unit circle to help us to evaluate all of these trigonometric ratios. So let's go for a minute to the next page and fill in our unit circle. So if we are over here, our coordinate pair is 1, 0. We are at 0 degrees or 0 radians. We could also know this when we come the whole way back around as 360 degrees or 2 pi. So again, if you are out here at this point, since it's a unit circle, this is 1 unit, and we didn't go up or down at all, so the coordinate pair is just 1, 0. If we come up here and make a 30-degree angle, so pi over 6 in terms of radians, if we think about what this would be, so let me draw in a quick little right triangle, and let's think about this for a minute. So theta here is 30 degrees, or pi over 6. We know if the hypotenuse is 1, because the radius of this circle is 1. And so if we would figure out the other side length, since it's a 30, 60, 90 right triangle, typically this one would be 1, but it's always x. This would be 2x, and this would be x times the square root of 3. In our 30, 60, 90 right triangle. So if we think about the fact that 2x has to equal 1, we understand that x is now 1/2. So this is 1/2, and then this would be square root of 3 over 2, because 1/2 times square root of 3 would just be square root of 3 over 2. So then the sine of 30 degrees is 1/2 over 1, which is just 1/2. And that's going to be the y-coordinate of this point, because that's this height right here. And then this is the x-coordinate. That would be cosine of theta, adjacent over hypotenuse. So square root of 3 over 2 over 1 would just be square root of 3 over 2. The next one, so if we come up here, we have a 45-degree angle, which is pi over 4 in terms of radians. And so now, if we think about drawing in our right triangle, again, this is 1, and in a 45-degree right triangle, we know it's isosceles. So 1 has to equal x times the square root of 2. So x must be 1 divided by the square root of 2, which when rationalized is square root of 2 over 2. So each of these sides would be square root of 2 over 2. So both x and y are square root of 2 over 2, because both the cosine and the sine of 45 degrees is square root of 2 over 2. All right, so if we build up then to a 60-degree angle, which is pi thirds in terms of radians. So now if we draw our right triangle, let me erase some of this other stuff so we can kind of see through the madness a little bit easier. All right, so now if we have a 60-degree angle, so right here we have 60 degrees, or pi thirds. So it's across from the longer side, so this side is x times the square root of 3. We know the radius of the circle is 1, so the hypotenuse here is 1. And 1 has to equal 2 times x. So again, we know that x would have to equal 1/2. And again, this would have to equal square root of 3 over 2. So it's now the y coordinate that is square root of 3 over 2, and the x coordinate that is 1/2. Because if we do the sine of 60 degrees, we'd get square root of 3 over 2. If we do the cosine of 60 degrees, we get 1 over 2, or 1/2. All right, so then if we are up here at this next point, we'd be at 0, 1, straight up from the origin, 1 whole unit. And in terms of degrees, that's your 90 degrees, or pi over 2 in terms of radians. And then we're just going to repeat these same things the whole way around, just changing the sign of them. Because remember, in your first quadrant, everything is positive. So they're all positive, nothing is negative. But when we come over here to quadrant 2, now we know that the sine and the cosecant are positive, but negative are cosine slash secant, tangent, and cotangent. So the sine are always the y values. So the y values are going to stay positive. The cosine are the negative, are the x values, and they're going to be negative. So as we come back around, this is going to be your 120 degrees, or in terms of radians, that's 2 pi over 3. And so now you're going to have negative 1/2 and square root of 3 over 2. This is going to be your 45-degree marker over here in quadrant 2. So 90 plus 45 gives us 135 degrees. And this is going to be 3 pi over 4 in terms of radians. And so now, again, x is negative, the y is positive, or cosine is negative, sine is positive. And then over here, this is our reference angle for the 30 degrees. So 180 minus 30 gives us 150 degrees, or 5 pi over 6 in terms of radians. So again, the x value over here is negative, the cosine, the y value is positive. And then if we come all the way around to here, this is your 180 degrees, or pi radians. And so now we're at negative 1, 0 for our coordinate pair. All right, so this next one, again, we've just gone 30 degrees further, so now we are at 210 degrees, or 7 pi over 6. And now both the cosine and sine are going to be negative down here. Both x and y are negative down here. If you go from 180, 45 degrees, you're going to be at 225, or 5 pi over 4. And so again, both of them are negative. And then if we go 60 degrees beyond 280, now we're at 240 degrees, or 4 pi over 3 in terms of radians. And again, it's going to be both of them negative. So negative 1/2 and negative square root of 3 over 2. And remember, down in this quadrant, the positive is the tangent and cotangent. Everything else is negative. So sine, cosecant, cosine, secant are all negative. All right, so down here, our coordinate pair is 0, negative 1. We are at 270 degrees, or 3 pi over 2 in terms of radians. So if we go 30 degrees beyond that, we're at 300 degrees. But remember, the reference angle here goes to the x-axis. So although we've only gone 30 from 270, it is 60 degrees from the x-axis. So the reference here is the 60 degrees. So 300 degrees, and we're at 5 pi over 3. And so here, in the fourth quadrant, we know the x values are positive. It's the y values that are negative. If we go 45 degrees beyond 270, we are at, 315 degrees, or 7 pi over 4. So again, x would be positive, y would be negative, or cosine is positive, sine is negative. And so if we go 60 degrees beyond the 270, we're at 330. Again, the reference angle there is 30 degrees. So this is 11 pi over 6. And again, the x value would be positive, the y value would be negative. Because down here in quadrant 4, cosine and secant are positive, sine, cosecant, tangent, and cotangent are all negative. And so that's what we call the unit circle. And once we have this, we can very easily use it to find the value of these trigonometric ratios. So I'm going to snap a quick picture so we can split screen it and have it side by side as we go through these examples. In your notebook, you can just lay it out flat, but here on my iPad, I'm just going to do this quick. All right, so first example here, we've got the sine of 150 degrees. So we come here to see 150 degrees on our unit circle. The sine is the y value, and so we see it's 1/2. And the next one, cosine of 300 degrees. So go to 300 degrees on your unit circle. Cosine's the x value, and so you see that is also positive 1/2. Tangent of negative 120 degrees. So we got to remember we're going counterclockwise, 120 degrees, which means we're not quite to 180. We're 60 degrees away from 180, which means we are at 240. And so if we look at that on the picture of our unit circle here, if we want the tangent is always going to be the sine over the cosine. So we got to do negative square root of 3 over 2 over negative 1/2. So negative square root of 3 over 2 over negative 1/2. But remember, we never divide when fractions are involved. Instead, we multiply by the reciprocal. And so these 2's are going to divide out, the negatives are going to divide out, and so you just have square root of 3 over 1, or just square root of 3. Because remember, tangent is always sine over cosine, because it's the opposite side over the adjacent side. And sine is the y value, cosine is the x value. All right, 7 pi over 4. So if I find 7 pi over 4 here on our unit circle, we're looking for the sine, which is the y value, and so we get negative square root of 2 over 2. Sine is negative down there in quadrant 4. All right, cosecant. So the cosecant of 5 pi over 6 would be the reciprocal of the sine. So if we go to 5 pi over 6, up here in quadrant 2, so the sine is 1/2, so if we take the reciprocal of that, we get 2. And then tangent of 3 pi over 2, 3 pi over 2 is down here. Tangent is always the sine over the cosine, but we can't divide by 0, so this would be undefined. Secant is the reciprocal of cosine, so we got to go back to 5 pi over 6 up here. So again, it's the reciprocal of the cosine. The cosine is negative square root of 3 over 2, so the reciprocal of that would be negative 2 over the square root of 3. But we'd have to rationalize that denominator, and so we get negative 2 square root of 3 over 3. All right, cosine of negative 135 degrees. So if we take the 360 minus 135 degrees, we get 225 degrees. So if you come on your unit circle, find 225 degrees, cosine's the x value, and so we get negative square root of 2 over 2. All right, negative 5 pi over 6. So if we take 2 pi minus 5 pi over 6, so that's 12 pi over 6 minus 5 pi over 6. We get 7 pi over 6. So if I go to 7 pi over 6 and find the sine, I see that it's negative 1/2. All right, so what if we want the angles and we're using the unit circle? We're going to find all of the ones that satisfy the given equation. So if we want the sine to equal negative 1/2, so we're looking for which ones have a y coordinate of negative 1/2. We know sine is sine is negative only in quadrants 3 and 4, the bottom 2 quadrants. And so we're looking for the y value to be negative 1/2, like we see here at, and since they said 0 to 2 pi, we know we're doing radians here. So we're going to say 7 pi over 6 is the first one, or the other one with a sine of negative 1/2 is 11 pi over 6. So 30 degrees is your reference angle there for that one. So cosine of theta is negative square root of 3 over 2. Well, for cosine to be negative, we're in the left 2 quadrants, quadrants 2 and 3. And so for a cosine x value of negative 3/2, we're up here at 5 pi over 6. Or 7 pi over 6. And again, 30 degrees was the reference angle there. All right, so secant of theta is the reciprocal of cosine. So this is the same as saying we need the cosine of theta to be negative 1 over the square root of 2, which is negative square root of 2 over 2. Again, for cosine to be negative, we have to be in quadrants 2 or 3, and it's the x value. So to have that negative square root of 2 over 2 for the cosine, we are at 3 pi over 4, or down here at 5 pi over 4. 45 degrees was the reference angle for that one. So once you have your unit circle filled in, it's real quick to go through and find the values that you need. It can be very helpful. It's just another option for how to find these things. Your other option, remember, is to draw your special red triangles.